Let's do an example. Say we have radioactive phosphorus 32. This will decay, and it has a half-life of 14 days. So every 14 days, half of our phosphorus 32 has reacted. So say we start with the initial amount of P32 is equal to 10 grams. And we want to know how much is left after 100 days. Okay, this is radioactive decay. So radioactive decay is first order. So we know which equation to use, the first order equation. So we use the first order rate expression. And I'm going to use A for everything to represent the reactant. In this case, it's phosphorus 32, but I'm just going to use A to represent all the reactants. Just easier for me. Okay, so we have the initial amount, 10 grams. We don't have the rate constant, but we can find it because we do have the half-life. So the rate constant, remember, is equal to negative the natural log of 1/2 over the half-life. So we can use this and substitute it in for the rate constant K. So now we can determine how much phosphorus 32 remains by just plugging in T, 100 days, and we can find K from the half-life, and we know the initial amount. So the amount of A is equal to the initial amount, 10 grams, times E to the negative K, and K is negative natural log 1/2 over T 1/2, so this is just natural log 1/2 over the half-life times the time, 100 days. This gives me 0.071 grams. So after 100 days, I only have 0.07 grams left when I started with 10 grams. So here for T 1/2, I would put 14 days. And you'll see that days will cancel. And so my exponent will be unitless, which it needs to be, and my only unit here is grams from the initial concentration.